Welcome back, everybody, to this video series with two parts. We are discussing the seamless migration in the terms of safely transitioning your large IoT fleets to AWS. If you haven't watched the first video, it's in the description. Go ahead and check that out. My name is Katja. For those who haven't watched that first part, I'm a senior database specialist here at AWS and have been an IoT specialist for 2 years. And I'm joined by my colleague Andrea.
Hello everyone, I'm Andrea Sickel. I work as Principal Specialist Solution Architect in the area of IoT for AWS. So back to you, Katja.
We are looking at the agenda for this video, which will start with a quick recap from part number 1. And then the rest of the time we're diving into the migration strategy, step by step, migrating those pieces from a self-managed broker over to AWS IoT Core. As I said before, if you haven't watched that first part, go ahead. We have the link in the description for you below. But if you want to just have a very quick recap, stay tuned and we're going to discuss a few pieces from video number 1. The first is the customer architecture. It's also good to recap just to have it on top of mind again. We have 10 million devices connected daily. No over-the-air updates are possible. They use MQTT3 and MQTT5, and our backend service are subscribed to the self-managed broker using shared subscriptions. We have over 80 backend services, and each service has around 20 to 100 instances. Those are arbitrary numbers, but a good start for us to discuss the architecture. The target we want to migrate to is have those same 10 million devices using a DNS server, in this case Route 53. Of course, you can use any DNS server of your choosing. And the important part here is connecting to AWS IoT Core as managed broker. From there on out, it stays the same: backend services, API gateway, and consuming applications. The migration strategy that we set as our big ambition was to have it as risk-free as possible in a controlled manner. We want to have a minimal error surface, and of course we are planning for no customer impact. So anything, looking back at the architecture we just saw, anything from API gateway and consumers, those should not be impacted by the migration itself. And we want to have a fast rollback strategy in place. I also want to mention here that in the next couple of slides, in the pretty much the rest of the video, we're going to mention a lot of methods you can use to have this rollback strategy in place. We're not going to really dive into developing and implementing that. So all the foundations are there, and you would need to go ahead and implement those measures that we are going to mention throughout. The question now is, how can we make this big ambition, this migration strategy, happen? What Andrea and I did is we are separating this into different phases. We want to have this, as I said, step by step and controlled, and this is how we're doing this. Phase number 1 is for a big migration like this. We need to prepare something in order to have everything in place to make a simple migration happen. So that's the preparation phase, where we are actually going to build up infrastructure to support the next phases. Then we're going to migrate the backends first. And after the backends are successfully migrated and finished, we're then going to move over and migrate the devices. And in the end, as we prepared something, as a migration also gets rid of infrastructure and services that are not needed anymore, we need to have a cleanup phase at the very end. Then let's have a look into phase number 1, or the first part, which is phase 0, because we're just preparing, we're not migrating anything yet. And the change to before is now that we're adding our target, which is AWS IoT Core. So since we're migrating backends first, you have to imagine that at some point backends will be communicating with IoT Core, but the devices are still communicating with the self-managed broker. So we need a way here to get the messages from the self-managed broker to IoT core, and then have the backends consuming the information from there. And once those are migrated and the backends are sending information to IoT core, that information must be passed back to the self-managed broker, because then we need to get the messages out to the devices. This is what you see here in green. And now we need to talk about the components we need to have the setup and also happening in architecture and infrastructure. So in order to do this, we are adding something we call the republishing layer. Now, devices that are sending messages to the self-managed broker, those messages from the devices should be sent over to IoT core so that the then migrated backends are consuming from there. We're calling this device to backend, D2B, right? This is number one. And number two is that if the messages arrive at the broker from the backend services that are migrated, we're forwarding those information over to the self-managed broker, and then those go out to devices. And this element, we call this backend to device. So B2D. Those two are at the moment empty, and this is an empty infrastructure. And you see here that the whole republish layer we have here as a container service. This is just an example. Of course, the compute is totally up to you to choose. And it's very simple code as well. So each of these components just has to subscribe to a topic and then publish this to the new broker. And this is how this whole infrastructure element looks like. As I said, very simple, and it can be deployed in multiple instances. So also the scaling up and scaling down part of this infrastructure can then accommodate our migration itself. So as I said, simple and empty in the very beginning. We're just preparing this for then actually those backends that we migrate in the next step. And this brings me to the actual phase one of the migration. And I would like to hand over to Andrea for this one.
Thank you, Katja. So let's deep dive on the backend migration strategy. Let's start a moment describing the usage of the republishing layers and why they are needed. Katja already gave an initial introduction. Here, we are going to visualize, with the help of some flows of messages, what's the meaning of those republishing layer in the flow. And we start with the device to backend republishing layer. So we have on the left devices that are sending messages. These are represented in an order M1, M2, M3 to the self-managed MQTT broker, relying on the pattern of share subscription that you see there as the path of the topic that the instances are using to subscribe, which starts with $1 shared, the share name for the share group, and then the topic that they want to subscribe. Each message is sent in a round-robin way to each of the different instances. Now, when we want to introduce the device to backend republishing layer, we need to guarantee the same scaling, the same load reaching the different instances. We don't want to overload any instance at this point in time. We want actually to keep or reduce the load on those instances, and we will see it also later in detail. So what happens here is we prepare the first instance of the republishing layer. That will join the group and will start to consume the load. And this message reaching the first republishing layer instance is republished to AWS IoT Core that reaches the migrated instance of service A, so instance 1. The same will happen for instance 2 and for instance 3. So it's exactly the same pattern. What is important here is that in order, as I mentioned, this is the very important point, to guarantee that we are not overloading the system with messages that are not expected on those layers, we need to do it step by step. Totally different is the point in this perspective for the backend to device republishing layer. So we start again here with no republishing layer yet. So we are having the instances from a backend perspective for service A publishing messages, which are also potentially for device 1 and device 2. Here we have changed the naming convention for the messages themselves. Like instead of having M1, M2, M3, we're speaking about D1.1 or D1.2, just to visualize the fact that they are for the target device 1 or device target 2. And in order for us to bring in the republishing layer, we can already prepare the entire configuration of the backend to device republishing layer at the level of the ECS cluster, as Katia mentioned before, subscribe them to the AWS IoT Core broker in order to be ready for the consumption. And then at that point, we can start moving one by one the instances that will be migrated already as part of the flow that we've seen before. But these instances will be, instead of publishing directly to the self-managed broker, publish against the AWS IoT Core. And in this way, we move forward with the second instance. Also here you see that the messages coming in from instance 2 are round robin across two backend to device instances at the republishing layer level and publishing against the self-managed broker. And we complete, in this case, the usage of the republishing layer between backend instances and devices by moving also the third layer. So this is still a description of the importance of the republishing layer. Let's check all of this together by moving into our initial architecture. So where we left before also with Katia presenting. We can see here that we have already all the instances ready for the backend to device republishing layer already deployed. This allows us to run initial some tests already, in the sense that we can trigger messages against the AWS IoT Core broker on topics that are purely test topics and see that they are republished against test topic on the self-managed broker, purely to see the infrastructure setup, the policies definition, all the configurations from a security and network perspective. After having done that, we can already initiate the first migrated instance communicating with the AWS IoT Core. And also here, this allows us to do some tests because we can publish against the AWS IoT Core, simulating the messages, see that they are consumed by the instance properly. And in order for us to guarantee what Katia was introducing before, we want to have a controlled and safe and reliable migration, allowing us to recover in case of issues at the quickest time. We are also considering here, it's not visualized in the presentation, the usage of a rule in AWS IoT Core that will store any message received in a persistent layer. This layer can be S3, can be any layer of your choice across the different actions available in the rule engine of AWS IoT Core. So after having prepared all of this, we are in a position of really starting the first migration of messages. So we do that by bringing in the first instance at the device to backend republish layer. And what happened at this point is that we have reduced the load on the service instances from 33%, because we had before 3 instances subscribe with shared subscription to the self-managed broker. Now we have still the 3 instances of service A on the bottom, plus 1 instance on the device to backend republish layer. So we are down at 25% of round robin across those. We can now see if everything works fine. So we are receiving the first messages on the migrated instance. This instance will republish back to the devices. If everything works fine, we can move ahead, removing the first instance that is not yet migrated from the picture, and continue the exercise with the second instance. So bringing in the migrated instance, the republish layer instance, and once we see everything working, we remove the second one, and we complete the same for the third instance. So with this exercise, we have migrated service A, and I will now scroll quickly through service B just to show you the exactly same behavior. So we are smoothly migrating service B with the same methodology, which will bring us to the final point of having migrated entirely all the service backends to AWS IoT Core, not having any backend communicating anymore with the self-managed MQTT broker. With this point, I hand over back to you, Katia, for the device migration part.
Perfect. Then after now that the backends are migrated, let's have a look at the device side of things. So here we have Route 53, and we have 100% of the traffic currently going to the self-managed MQTT broker. We now want to use a weighted routing policy. So of course, you can also use something else depending on the demand of your migration. You could use geo-based routing, for example. But here, for simplicity and just to show that it works, we use weighted routing. we have 100% of the traffic currently going to the self-managed broker, and we're now going to shift the traffic. And the speed of the shift depends very much on what we have internally documented and what our requirements are. But now we're going to slowly shift from 100% and 0% to 98% going to the self-managed broker and 2% of the traffic going to AWS IoT Core. I also want to mention here that in IoT Core, we are using something that Andrea mentioned in the last video, actually, which is just-in-time registration. So the first time a device comes up at or connects to AWS IoT Core, the certificate and the policy and the device will be created based on this mechanism that we're using. So this is what we leverage as part of the migration. So we have now 2% of the traffic going to IoT Core, and now we can test out if everything is working just fine and just as expected. So also here we see this fast rollback strategy. We could just shift the traffic back to our self-managed broker and everything would continue to work as before. But now let's assume we're successful, everything works as expected, we're shifting more and more. So now we shift to 90-10, we shift over to 50-50, and then 90 for IoT Core and 10 to our self-managed broker. And in the end, with 100% going to IoT Core, 0% of the traffic goes to our self-managed broker, which means that there's all devices connecting to AWS IoT Core. One thing I still want to mention here, also still going back to the fast rollback strategy we mentioned before as our ambition, all the messages from the backends that come to AWS IoT Core are still being republished using the republishing layer to the self-managed broker. So at any point in time, even now after we completely migrated devices, we could still point the devices back to the self-managed broker and still have the messages there as well from the backends that can be received and interacted with. This all in all completes our device migration, and I want to hand back over to Andrea for the cleanup phase.
Thank you, Katja. So we are in the final part of our migration strategy. As Katja mentioned, is the cleanup phase. And we need to take care of cleaning up the republishing layer and the self-managed broker, which are at this point still generating traffic, still producing messages against the self-managed broker. So in a way that allows us not to break the monitoring or the systems of the self-managed broker, the first part that we do is to terminate the republishing layer so that we isolate entirely the self-managed broker. With this step, there is absolutely zero traffic hitting the self-managed broker instances at this point in time. The next obvious step is going to be to clean up also or terminate the instances of the self-managed broker, which brings us at this point to the architecture that we had in mind, an architecture that allowed you to migrate the millions of devices to AWS IoT Core, and not just the devices, but also the backend services altogether. And we've done that in a way that followed all the strategy requirements that Katja exposed before. We made it risk-free, ensuring that there was always a way to recover, so having a controlled approach with absolutely minimal error surface. We tried to reduce to the minimum the customer impact, and we managed to, and we have also described how, to have execute a fast rollback in the case in which something would go wrong. With this, we are pleased to have had you joining us in this session. So we hope that you enjoyed the mini-series. We incentivate you to use the comment feature of the YouTube channel to bring us ideas of topics that you might want to discuss in terms of large and complex migrations, because we have described today one example of migration. So this might be an input for us for one of the next videos. So thank you very much and go and explore.
Perfect. Thank you so much.